Okay, so I just want to go over some examples that are like those in our homework tonight, page 173, 35 to 38 all. And I'm using some simple examples here to show you the concept that you're going to be using. And the concept is if you have an equation and you have the same base on both sides, then the exponents must be equal. So for example, if you have x to the a power equals x to the b power, that means a has to equal b. All right, this is what we're going to use to solve these types of problems. So let me just give you a really simple one. I have 3 to the x power equals 1/9. All right, 1/9 equals 1 over 3 squared. Because my goal here is I want the same base on both sides of my equation. So I want a base of 3 on both sides. Now this is something that we're going to be learning in the future. And if I have an exponent in the denominator, I can move it up into the numerator by changing its sign. So it looks like this. 3 to the x power equals 3 to the negative 2 power. Now I have the same base on both sides, and so I know that the two exponents must be equal. So x must equal negative 2. All right, let's do another example. And it's really helpful if you know your multiplication tables and your powers by heart. It's really helpful here. Now what I want to do is I want to get the same base on both sides of this equation. So it looks like this or like this. All right? What I can do is write 25 as 5 squared. 125 is 5 to the 3rd power. I'm going to use my law of exponents on the left-hand side. My power rule says I multiply these powers. So this is 5 to the 2x power equals 5 to the 3rd power. All right, now I have the same base. The base is this number, the 5. Up here, my base is x. But now I've got a base of 5, so it means my two exponents must be equal. So it means 2x must equal 3. Solve for x by dividing both sides by 2, and I have x equals 3 over 2. So what I want to do now is let's go to the first one that we have for homework. And they're a little bit more complicated. The first one that we have is 35. We have 3 to the 5n power equals 3 to the 5th times 3 to the 2n raised to the 2nd power. Now, I don't want to take 3 to the 5th and put that in my calculator and find out what ginormous number it is. What I can see is that I want to get the same base on both sides. And that base I can see right now is going to be 3. All right? So what I'm going to do is use my laws of exponents to simplify what's on the right-hand side here. So first of all, remember, if you have a power outside the parentheses, that's always the first thing you do. So I'm just going to simplify the right-hand side. The left-hand side is going to stay the same. And this is going to become 3 to the 2n times 2 power, which is the 4n power. Now, the second thing I'm going to do is I'm going to use my product rule. My product rule says this: x to the a times x to the b power equals x to the a plus b power. My base is 3, all right? It's just a number instead of an x. So this is 3, and the power I add my exponents is 5 plus 4n. Now I have the same base on both sides of my equation, which is 3. So my two exponents must be equal. And so what this means for me is 5n equals 5 plus 4n. Now all I need to do is solve for n. So subtract 4n from both sides. And I'm going to get n equals 5. All right, let's try 36. This is the next one in our assignment. All right, so first of all, I can already see that what I want to use as my base on both sides of this equation is the number 2. I'm just going to use my laws of exponents to simplify my left and right hand side of my equations. Remember, if I have a power outside the parentheses, that's the first thing I want to do. So I'm going to do that first on the left hand side. I'm going to have 2 times 3n gives me 6n. So this is 2 to the 6n power. Here, multiply the n and the 3 and I get 3n. So this is 2 to the 3n times 2 to the n plus 6. Now, I'm going to use my product rule that says that I'm going to add my exponents. I'm going to do that on the right-hand side. So I have 2 to the 6n power equals 2 to the 3n plus n plus 6 power. So now I know that since I have the same base on both sides, those two exponents, as long as they are equal. So that gives me a new equation so I can solve for n. So I know 6n equals 3n plus n plus 6. Combine like terms on the right-hand side, and I've got 6n equals 4n plus 6. Subtract 4n on both sides. And I have 2n equals 6. Divide both sides by 2. And this is going to give me n equals 3. That was my whole goal, to solve for n. All right, let's try one more. We'll do 37, and I'll leave you to do 38 on your own. So let's do 37 together. So 37 is 3 times 9 to the 2n power equals 3 to the n plus 1 raised to the third power. Now, I don't have the same base everywhere here. I've got 3's and 9's. But the good news is I can rewrite 9 as 3 squared. And if I do that, then all my bases are 3's. And that's what I want to do. I want all my bases to be the same. So I'm going to rewrite 9 as 3 squared. So I've got 3 times 3 squared. That is raised to the 2n power. And on this side of the equation, I already have the right base, so I just need to multiply my exponents. I'm going to use my power rule. So this is 3 to the 3 times n plus 1 power. In my next step, I'm going to distribute that. All right, back to the left-hand side, I'm going to use my power rule here to multiply these exponents, and I get 3 times 3, 2 times 2n is 4n, equals 3 distribute that 3, and I get 3n plus 3. Now I'm going to use my product rule on the left-hand side. Remember, the power that is here that you don't see is a 1. All right, so in order for me to add my exponents, I'm going to add 1 plus 4n. So this is 3 to the 1 plus 4n power equals 3 to the 3n plus 3 power. Now I have the same base on both sides of my equation, so I know that my exponents are equal to each other. So that gives me a new equation. 1 plus 4n equals 3n plus 3. I'm going to solve for n by subtracting 3n from both sides. I have 1 plus n equals 3. Subtract 1 from both sides, and I get n equals 2.